Alright, let's take a look at some potential energy. Potential energy is simply energy that is stored. And so we're going to mainly focus on the form of potential energy that deals with gravity. So we look at it as gravitational potential energy. I'm going to say PE for potential energy. So this is when you have an object that is some distance above typically the ground, like on the earth here. So you might have a height, right? Height, how high is it above the ground here? So because it is that particular distance above the ground, it has a stored energy in it. We've moved it within that gravitational field, the force of gravity is acting on it, so it now has the potential then to fall back down to the ground. So when we look at gravitational potential energy, we will simply calculate that, PEG, with taking the mass of the object times the acceleration due to gravity times the height or the distance the object is above the ground. Now, as you'll recall, the mass times the acceleration due to gravity of an object is also known as the weight of the object. So we take the weight of the object times the height. That is also the gravitational potential energy. So depending on what information you're given in the particular problem maybe that you're working on, you can look at your knowns and determine which one is going to be the best version of the potential energy equation that you'd want to use. So let's just take a look at this box here. Let's say this box has a mass of 42 kilograms and lift it to a height of 10 meters off the ground. So my potential energy, gravitational, I have mass and I have the height. So I'm going to want to use this equation right here since I'm given the mass. So I've got 42 kilograms times the acceleration due to gravity, 9.8 meters per second squared. All that times the height, 10 meters. So we finish this up. The result of that, 42 times 9.8 times 10 is 4,116. And then our units, we have kilograms times meters times meters. We have kilograms times meters times meters, and then we have seconds squared here on the bottom. So we'll take a look at the units a little bit here. That's kind of messy looking with all that. This right here is a Newton. Kilogram meters per second is a Newton, and we still multiply that times meter, and we know then that newtons times meters is a joule. So our potential energy, our gravitational potential energy of this box that was 10 meters above the ground is about 4,116 joules of stored energy that can cause change, right, within the gravitational field for that box. That's basically it. You might have a problem where you're given the weight of the object. I might tell you directly it's 4,000 newtons, and then you don't have to go through this process right here, multiplying it times the acceleration due to gravity. But make sure you remember that kilograms, right, kilograms is a unit of mass. Right, that is not the same thing as weight. Weight is going to be given to you in metric system in newtons. So make sure you understand the difference between those units there, and that'll help eliminate some problems you might run into later in these problems.